Welcome to this video in which I'll be going through the solutions to the VCAA 2022 Northern Hemisphere Timetable Maths Methods Exam 2. Before we get started on the solutions, just double check to make sure that your CAS is on the right settings. So in your settings menu, make sure that your display digits are on float, your angle is on radian, and your calculation mode is exact. The most important really are the angle radian and the calculation mode exact. Especially if you do further maths, you want to double check that these are on the correct settings. Alright, so moving on to the actual questions, we're going to start with section A, which is the multi-choice section. So question 1 asks us to take a function f and the inverse f neg 1, and we are told that they're all 1 to 1. We are also told that the value of the function at x equals 1 is 5, or f1 equals 5. We're also told that f3 is 7 and f8 is equal to 10. We are asked to find the inverse function at 7 and the inverse function at 5. Now, in order to actually answer this question, what we need to do is find the relationship between the original and the inverse. So for the original, you will have fx equals y, and what this means is when you go over to the inverse, what actually happens is the inverse function at a particular y value is equal to the original x value. That's because when you swap between a function and the inverse, x and y basically perform a swap like that. So all we need to do is look for y values of 7 and 5 in the original information. So y value of 7 is right there, which gives an x value of 3. And a y value of 5 is there, which gives an x value of 1. So we're looking for 3 and then 1 respectively. That is the answer B. Moving on to question 2, we are looking at tan theta equals neg 3/4, and also theta is across one revolution of the unit circle. Our job is to find the value of cos theta. So the best way to answer a question like this is to simply draw a triangle as shown, and then in one corner put theta. It has to be a right angle triangle, by the way. And we see that tan is neg 3/4. We're going to, I guess, ignore the negative for the moment and just look at the side lengths. So if tan is 3 and 4, that's opposite over adjacent. So opposite 3, adjacent 4. And now using Pythagoras theorem, that's pretty straightforward. We'll get 5. Or you just need to know that we have a 3, 4, 5 triangle. So from this, we know that the value of cos will be adjacent over hypotenuse, which will be 4 over 5. Now, given that we are looking at the entire unit circle domain, the value of cos could be positive or negative. Just in case you're wondering, because tan was negative, it means that we are going to be in quadrant 2 or quadrant 4. In quadrant 2, cos was negative, and in quadrant 4, cos is positive. So both values, positive or negative 4 and 5, are allowed, which means our answer is E. Alright, moving on to question 3. We have a function f with rule fx equals 2 log e 16 minus x, and we want the maximal domain. This one can be done by hand, but you can also check it on the CAS. So on a brand new calculator page, we are going to type in the command domain, domain, and you open a bracket. Or you can even find domain in the book command as well. It's up to you. So we're going to type 2, and instead of writing log e, I'm just going to go control e to the x and get ln, and go 16 minus x, and then comma x. Enter. So we get negative infinity to 16, not including either. So we're looking at option E. So x is basically less than 16. You can get this answer via multiple methods. Moving on to question 4. We have g of x given to us as 3x plus a, where a is a real constant. We are also told that the composite function g of 2 is equal to 10. So the best way to, or the easiest way I reckon, to answer this question is simply define g of x in the CAS. So g of x is defined as 3x plus a. Now let's work out the left-hand side of this. So we have g of, we can actually use the var command as well. G of 2, enter, and we get 4a plus 18. So menu 3, 1, and we have 4a plus 18 is equal to 10. Let's solve that for a, and we end up with a equaling -2. And there you go. That's option B. Moving on to question 5. We are told that we have a continuous random variable with a specific PDF given by this function f over here, and it's simply a times cos 2 pi x plus 3 pi over 2, and it's defined between 0 and half. Our job is to find the value of a. Okay, so this one we're going to just go straight into the calculator and shift plus, perform an integration from 0 over to half, and then type in a times. Make sure you put a times between the a and the cos. Trig cos, and then 2 pi x plus 3 pi over 2. 3 pi over 2. Close that bracket and go all the way to the end, dx. And that is the integral done. So now we need to go menu 3, 1. You can all do it in one line as well. Solve. That answer is equal to 1 because we know the total area needs to equal 1. And we're going to solve for a, and we end up with a equals pi, which is option C. Excellent. So moving on to question 6. The line with equation y equals mx plus 1. So we have a straight line, and a parabola with equation y equals 3x squared plus 2x plus 4 intersect at 2 distinct points. So that's crucial. We're intersecting at 2 distinct points. Our job is to find the values of m. So what we're going to do is I'm simply going to write the equation for the parabola, 3x squared plus 2x plus 4, and equate that to the expression for the straight line. Then we're going to take everything over to the left-hand side. So 3x squared plus now 2x minus mx is 2 minus m all times x, plus 4 minus 1 is plus 3, and that equals 0. So the solutions to this equation will provide the x values of the intersection points between the parabola and the straight line. We know we want 2 distinct points of intersection, therefore we want 2 distinct solutions to this equation. In other words, we want the discriminant of this quadratic equation to be greater than 0. So in order for that to happen, the discriminant is b squared minus 4ac. We want that to be greater than 0. So solving this on the CAS, menu 3, 1, solve 2 minus m squared minus 4 times 3 times 3, and greater than 0, so control equal, greater than 0, comma m, and we end up with an answer of m less than -4 or m greater than 8, and that right there is option D. Moving on to question number 7. The graph of y equals f of x is shown below. The corresponding graph of the inverse is best represented by. Okay, so if you want the graph of the inverse, the best way to really answer this question is take your page, draw the original on the bottom right, and then simply flip it. So if I just draw the original, it looks like it starts at -1, -3, and goes up to about 4,5. So roughly speaking, it goes like this, like that. So if you take that and you flip it over, what you'll end up with is a graph that looks something like this. So, which of these graphs appear as shown? That would be option C. There you go. So that is the inverse. The alternative way to do it is simply take your original and basically draw the line y equals x as shown, and simply reflect your graph in that line. Right, moving on to question number 8. The range of the function with rule y equals 4 minus x squared plus log e x plus 2. So for a range question, it's always recommended to simply sketch a graph. So Control I, add graphs, and we're simply going to type in this function, square root 4 minus x squared and then plus log e, so ln of x plus 2, enter, and we end up with a graph that looks like that. Now, I know that this left-hand side part of the graph does go all the way down to negative infinity because of the log part of the equation. So what we've really got is the domain of this section here is from negative 2 to 2, and the domain of that section there is from negative 2 to infinity. So the log is basically dominant as you approach x equals negative 2, which means it goes all the way down to negative infinity, which means the options could only be b or d. So those are the two options we've got because it starts at negative infinity. To get the upper limit, we simply need to work out what the maximum is. So menu, analyze, and maximum, and we're going to find the maximum, and it's 2.87. Right, so clearly the graph does not stop at 2.8, so it can't be b, and in option D, we have 2.9 there, but doesn't reach 2.9, and that is correct. So the question is asking for an interval that contains the range rather than is the range. So in option D, that entire interval contains negative infinity to 2.866, etc. So negative infinity, comma 2.8668 dot dot dot, and that right there is the range of the function. So that is certainly contained within that. So the option D is correct. All right, moving on to question 9. A survey on sleep habits was conducted using a random sample of 40 people. So 40 people right there, that is n equals 40. And we've got 30 of the survey participants that they reported that they would like to sleep more. So that means our number of successes, little x, is equal to 30. So we're looking for a 90% confidence interval. So that means z equals 1.64. This should be in your reference book. And we want that confidence interval for the proportion of the population who would like to sleep more. So this one, we can't unfortunately use a calculator because it would give us the result. We're really looking for a working step. So you need to go to a formula sheet and see that the, formula for a confidence interval looks as follows. So it's p hat minus z times square root of p hat minus 1 minus p hat over n, comma, and the exact same thing, but with a plus. Plus z square root p hat 1 minus p hat all over n. You get the gist from that. So what we're going to do is we know that p hat is equal to 30 over 40, which is 0.75. That's just 3/4. And our z value, as we said, was 1.64. So we just need to basically plug everything in. So what we get is 0.75 minus 1.64 square root, and we'll have 0.75 times 0.25 all over n, and we saw that n was 40. And basically the second part would be the same as well. So you're looking for this exact setup right there, and it looks like, looking at the options, we're looking at option A, 0.75 minus 1.64. Just double check that it looks right, and the right hand side looks like it's the same thing as well. Perfect, so the answer is A. Right, moving on to question 10. We have a PDF for the distribution for discrete random variable x, and we want the variance. Okay, so we know that the variance is given by var of x equals e of x squared minus e of x all squared. All right, so e of x squared, that's just the top squared times the bottom, so we'll go back, control left, go back to our calculator. So we have 0 squared times 0.1 plus 1 squared times 0.4 plus 2 squared times 0.3 plus 3 squared times 0.2. So 3.4 is the expected value of x squared. Now for e of x squared, we're going to do the same calculation but just without the squares. So we have 0 times 0.1 plus 1 times 0.4 plus 2 times 0.3 plus 3 times 0.2. And that gives us 1.6. So therefore the variance is 3.4 minus 1.6 squared. We get 0.84. And that there looks like it's option D. Excellent. So just a straightforward calculation right there with all the different components. Moving on to question 11, we are given a glass window with a few dimensions on it. Height is h, width is 2r, and a semicircle of radius r. We are told that the perimeter of the window is 8 meters. So what this means is we'll need to create a constraint equation between r, h, and the 8. So the perimeter is 8, which means that 8 is equal to basically the sum of all the sides. So we have two heights, so this one plus that one, plus 2r, which is the base over there, plus we need basically this curved section. So that curved section is half of a circle, so that is half of 2 pi r right there. So 8 equals 2h plus 2r plus pi r, and that's it. So that is a constraint equation that connects the values of h to the values of r. So we want the area in terms of r only. In other words, we want to get rid of h. So from this equation, we can solve for h and get h equals, and we can use a calculator for this one, menu 31, 8 equals 2h plus 2r plus pi r. And we want to solve for h, and there we go. So we get h equals what looks like negative bracket pi plus 2r minus 8 all over 2. So that's the height in terms of the radius. So we want the area completely in terms of r. So what we'll need to do now at this stage is basically work out the formula for the area. So what we've got is area equals the area of the rectangle plus the area of the semicircle. Area of the rectangle, that's pretty straightforward. That's length times width, so 2r times h, plus the area of the semicircle is half of pi r squared. So basically what we're going to do is we're going to take this I guess expression for the height and put that into this formula over here. So that's 2r times negative pi plus 2r minus 8 all over 2, and then plus half pi r squared. So let's use the CAS to help us simplify that over there. So what we're going to do is I'm just going to type in 2 times r times h, and then plus half pi r squared. So half pi and then r squared. And we're going to say control equal left enter given, and then h equals that. Excellent. So we end up with this thing here. Now it doesn't look like any of the options, so we're going to expand it. Menu 3, expand, take that answer, and there we go. So we have an answer of what looks like 8r's positive minus 2r squared minus pi r squared all over 2. Looking at the 5 options, does that align up with anything? 8r minus 2r squared minus pi r squared on 2. That looks like option E. So let's go with that. There, that is how you work out the area in terms of just the radius. Right, moving on to question 12. The weights of frogs from a certain species have a normal distribution with a mean of 56 grams. It is found that 5% of the frogs weigh more than 77 grams. Okay, so here what we're going to do is the weights, as they said, are normally distributed with the mean of 56, but we don't know what sigma is, so just comma sigma squared. We are told though that PR of W greater than 77, so the probability of a frog having a weight more than 77 grams is equal to 5% or 0.05. We're going to use inverse normal, but in order to use inverse normal, we need a less than or equal to. So we're going to now take the opposite. W greater than 77, the opposite of that is W less than equal to 77, and the opposite of 0.05 is 0.95. So using this, we're going to go to we're going to standardize and then be able to get the value of the standard deviation. So standardizing, we will get PRZ is less than or equal to 77 minus mu, which is 56, over sigma, and that's equal to 0.95. So what's going to happen is we're going to solve menu 3.1, solve, open a fraction, 77 minus 56 over sigma, I'm just going to call that S for simplicity, is equal to, now we're going to do inverse normal, menu 553, inverse normal, and the area is going to be 0.95. And after that, we're going to ask the calculator to solve for S. And we end up with S equals 12 point, so sigma equals 12.767, dot, 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 and that roughly translates to 12.77 to 2 decimal places. Perfect. So let's go to question 13. So fx is g of x times root 1 minus x squared, and we want the gradient of the tangent to the graph of f at the point where f crosses the vertical axis. So all those terms simply mean f dash of 0. So the gradient of the tangent is the derivative, and the point where f crosses the vertical axis, that's the y-axis, that's x equals 0. So we need to first work out what f of x, or what f dash of x is equal to. And we can use the product rule by hand, but we can use our calculator to help us as well. So I'm going to go f of x and define it as g of x multiplied by the square root of 1 minus x squared. Enter, and we get done. So now shift minus d dx and put the function there, f of x, enter, and there we have it. Okay, so f of x, g of x is defined. So if that does happen, what you can do is you can go menu, actions, delete variable, and we can delete the function g, because g was defined in a previous multiple choice question. So going back and redefining it, and there we go. So f dash x is equal to the derivative of g, so g dash of x, multiplied by root 1 minus x squared, minus x times g of x over square root of 1 minus x squared. So what we need to do is basically plug in x equals 0 over here. So f dash of 0 equals g dash of 0 multiplied by, plug in 0 into there, which gives us 1, minus, and then 0 into that. Well, as soon as x equals 0, the entire thing becomes 0. So that's just 0 over there, which means f dash 0 is actually just g dash of 0, which is option D. Excellent. So moving on to question 14. The graph y equals sine x is subject to the transformation given by that matrix. The resulting graph can be described by. Because this is a simple matrix transformation question, it's probably not as efficient to multiply out the matrix. I'd recommend just simply identifying the transformations. So the 2 and the -1, what the 2 is, it's a dilation by factor 2 from the y-axis. That's what the 2 is. And the -1 is a reflection in the x-axis. So we've got that. And then finally, the -2 and -1, those translate, pardon the pun, into a translation 2 left and 1 up. So applying these transformations in that order to y equals sine x, we'll do this. When you dilate by a factor of 2 from the y-axis, what will happen is you'll end up with sine of x over 2. Reflecting the x-axis, that will put a negative at the front. And then translation 2 left and 1 up. So what the 2 left does is it will change x to x plus 2, and then the 1 up will go plus 1. So just tidying that up a little bit, that'll be negative sine of half x plus 2, and then plus 1. So all of the options start with 1, so just put the 1 first. 1 minus sine half x plus 2, and that right there is option D, 1 minus sine half x plus 2. Perfect. There we go. Question 15. We've got another discrete random variable, and we've got a table here. So we have a sample of size of n equals 4. We want the probability that the sample proportion is less than or equal to 1/3. And if you notice, all the options are numerical, whereas the probabilities are all in terms of k. So first thing we'll do is we'll find the value of k. We'll do that using the calculator. Many 3, 1 for solve. K, so k plus 2k plus 3k plus 4k plus 5k is equal to 1. And solving that for k gives us k equals 1 and 15. So k equals 1 and 15. So we have that sorted. Now what we'll do is we'll convert that sample proportion random variable into an x random variable. So when n equals 4, the value of, or the values of capital P hat will be all the x values divided by 4. So PR of P hat less than or equal to 1/3 is equal to PR x over 4 is less than or equal to 1/3, which then translates to PR x less than or equal to 4/3. Now 4/3 is just slightly a tad over 1. So if you're less than or equal to 4/3, we are basically on x equals 0 and x equals 1. So that is simply k plus 2k, which is 3k, and 3 times 1 on 15, that should be 1 over 5, which is option E right there. There you go. So that is how you work out that probability. Right, moving on to question 16. Every day Lucy goes to school by one of 3 methods: car, bus, or walking, and the probability that she goes by car is 0.45, bus is 0.2. So walking would be 1 minus the sum of those two. When she goes by car, the probability that she arrives early. Okay, so as soon as you read that, you straight away notice that we've got sequential events happening. So what's going to happen? Well, she has 3 different modes of transport. There's car, bus, and walking. Following a mode of transport, then she will either arrive early or she will not arrive early. So filling out the tree diagram, and what we've got over here, E and E dash as well. Right, so the probability that she goes by car is 0.45, so that's 0.45. Bus is 0.2. So 0.45 and 0.2 is 0.65, which means the remainder is 0.35. When she goes by car, the probability that she arrives early is 0.6. So 0.6 up there, and then 0.4 below that. When she goes by bus, the probability that she arrives early is 0.1. So 0.1 and 0.9. And when she walks, she always arrives early. So that's a 1 and a 0. So what's the question? What is the probability that Lucy goes to school by car given that she arrives early? So this question is asking for PR of car given early. So to work this out, let's use the formula sheet. So that is the intersection of the 2 divided by the probability of the second. So probability of C intersection E, let's use a highlighter for this one. So C intersection E, basically you go along this and you go along there. So that is 0.45 times 0.6 divided by the probability of E. Okay, so to get the probability of E, we need to basically look at the 3 different ways to get E. So we have C and then E, or B and then E, or W and then E. So let's find those probabilities and add them all together. So of course we have the 0.45 times 0.6 at the top, plus 0.2 times 0.1, plus 0.35 times 1, and put that into the calculator. So control divide to get the fraction. 0.45 times 0.6 over 0.45 times 0.6 plus 0.2 times 0.1 plus 0.35 times 1. And we end up with an answer of 27 over 64 exactly. And that is option A. So 27 over 64. Perfect. Not too many to go. So question 17. The coordinates of the point on a curve with equation y equals root x that are closest to the point 4, 0. So the best way to do this is to simply sketch a very rough graph to understand what is actually happening. So y equals square root x looks like this. That's y equals square root x. And the point 4 comma 0 is about here, 4 comma 0. So what this question is asking us to do is to basically find the point on the square root graph that is closest to the point 4 comma 0. So what I'll do is I'll just label that point there. That'll be x comma root x. Normally we'd say x comma y, but we know that y is root x, so it's x comma root x. What we're then going to do is take the distance formula. I'm going to call it L. L for length of line. So that's the square root of the difference in x values, so x minus 4 all squared, plus the difference in y values, square root x minus 0 all squared. So let's go to the calculator and define this. So L of x is defined as the square root of bracket x minus 4 close bracket squared plus bracket square root x minus 0 close bracket squared, enter. So that is the function defined. And if you want to write it out, you can press var, find L, put x there, and you end up with this. So that's the square root of x squared minus 7x plus 16. Okay, so now that that's done, we want to find the closest point. So basically we just find the derivative, equate it to 0, and then we'll get the x value. So doing this all on the calculator, shift minus ddx of L of x, that's the derivative, menu 3, 1, take the derivative, equate it to 0, comma x, and we get x equals 7 over 2. So therefore the coordinates, we need the y value, so we just need the square root of 7 over 2, because y equals square root x, we end up with root 14 on 2. So the coordinates of the point that are closest are 7 on 2, comma, root 14 on 2, which is option C. There we go. Right, question 18. So at the point where x equals k, the tangent to the circle given by the equation x squared plus y minus 1 squared equals 1 meets the positive direction of the x-axis. Okay, so we can sketch this graph. Well, let's do that on a graphs page. Control I, I'll add graphs, and that is a relation. So I'm just going to press delete and then press 6 for relation and type in that circle. X squared plus y minus 1 squared is equal to 1. There you go. So what looks like is we have a circle of radius 1 centered at the point 0, 1. So this is what it looks like. It looks more like an oval. Maybe let's try that again. There we go. Okay. So we have a tangent that meets the positive direction of the x-axis at an angle of 135. Right, so there's two possible tangents. One up here. There you go. So that right there would be 135 degrees. But there's also another point on the diametrically opposite, exactly the same thing. That will also be 135 degrees. So given there's two options, we need to look at all the possibilities of here. If you look at A, B, C, and D, they all have negative values, and K is the x value of the tangent. So clearly, it cannot be the right one. It has to be the left one. So the left one exists on the bottom half of the circle. So what we're going to do is we're going to go back to the original, and we're going to do a menu 3-1 for y. Solve, and then we're going to do x squared plus bracket y minus 1 squared is equal to 1, comma y, and you'll get two answers basically. You want to take the one that corresponds to the bottom. So the one that corresponds to the bottom is the one with negative. So let's write that out. So that is y equals 1 minus root 1 minus x squared. That's the equation of this bottom half of the circle. So in other words, what we need is we need to take the derivative and equate that to tan of 135, because the gradient is equal to tan of the angle. So tan 135. So what we need to do is basically do a solve on the cas and then take the derivative of 1 minus root 1 minus x squared, and then basically equate that to tan of 135 and solve that for x. Let's see how this works. So shift minus d dx, and we have 1 minus square root 1 minus x squared, and we're going to do, let's plug in x equals k, by the way. So take that, control equal, left given, x equals k, enter, and there we have that. And now menu 3.1, take that and equate it to tan of 135 degrees. Now, I know we're in radians mode, but the easiest way to put degrees is press the pi button and press it a few times until you get to degrees, or you can just press down and enter, and there you go. And now we're going to go comma k. There we go. K equals negative root 2 on 2, which is the same as negative 1 on root 2. So k equals negative root 2 on 2, which is the same as negative 1 on root 2. There you go. That's the answer to question 18. Right, question 19. The set of values of p for which x cubed minus px plus 2 equals 0 has 3 distinct real solutions. Okay, so what we're talking about is the graph of this. We want 3 x-intercepts. So the best way to do this really is we're going to use a slider on CAS as much as possible, or as much as we can handle. So 3 x-intercepts. So again, Control I, let's go to a graphs page and type in this. X cubed minus p times x plus 2, enter, and it'll ask you to create a slider. Of course, go OK. And there we go. With p equals 1, as you can see, there's only one x-intercept. Now we change p to 2, still one x-intercept. Let's go the other way, 0, neg 1, neg 2. Oh, that doesn't look good. So as p becomes smaller or goes towards negative infinity, basically you lose turning points on the cubic. So that's not going to help. Let's go 0, 1, 2, and 3. So when p equals 3, it appears there's only 2 x-intercepts, but we want 3 distinct solutions, not any repeats. So you go p equals 4 and p equals 5, and there you go. We now start getting multiple ones. If you want to double check that, you can then change that 5, double click it, change to something like 10, and again you will see 3 x-intercepts. So it appears that when p is strictly greater than 3, we will get 3 distinct real solutions. That is, p is element of 3, infinity. There we are. Right, now we're on the final multiple choice question. Woohoo! So, consider the graph of 2 circular functions f and g shown on the axes below. What do they want? Well, we've got what appears to be a sine graph and what appears to be a tan graph. On the interval x element of 0 to 4, right? So both of these functions have a domain from 0 to 4, so that's good. So over the interval 0 to 4, the number of x-intercepts for the graph of the product function h equals f times g. Right, so we're going to basically find the product of these two. So again, we can use our calculator for this, but we need to know what the actual functions are. So the first one looks like it's a sine graph, y equals fx equals sine. Now it'll be something x. What we do is we know the period is 2, so the coefficient of x is going to be 2 pi over 2, which is pi. So that's sine of pi x. So we have sine of pi x is the equation of the first graph. So sine of pi x. Now for the second one, we've got gx, again that equals something tan of something x. Something x, what that something is? Well, as you can see, the asymptotes are 2 apart, so the period of this is also 2, but because tan has a period of pi over n rather than 2 pi over n, that's pi over n, and n would equal pi over 2. There we go. So tan of pi over 2x. So you can answer this question graphically or on a calculator page. So let's look at the calculator page. Menu 3.1. We want to solve the product of these two. So the product of h of x, in our case, is going to equal sine of pi x multiplied by tan of pi over 2x. So that is that. So solve trig sine of pi x multiplied by tan of pi over 2x, and we want that to equal 0. Solve for x using a domain of 0 less than equal to x and less than equal to 4. Enter, and there we have 0, 2, 4, so that's 3 solutions. Let's double check that on a graph. So Control I, add graphs, and let's type in that same thing. Sine of pi times x and tan of pi on 2 times x. And there we go, between 0 and 4. So menu for 1, change the x values to 0 to 4. And there we have it. So x equals 0, x equals 2, x equals 4. There, that's 3 x-intercepts, which means that the answer is option A. And there we have it. That right there is the end of section A, which is the end of the multiple choice section. Okay, so moving on to section B, the extended response section on the exam. Before we get a start on this section, it's always a good idea to start a brand new problem on the CAS. The way to do that is to press doc, then 4, then 1, and then add a calculator page. This way, you can see that the calculator is now at page 2.1 as problem 2, section 1, or page 1. So the variables in here will not affect all the other variables in problem 1 or problem 3, etc. So question 1 looks like it regards this function f of x. So before we get any further, let's define that. F of x is defined as negative 2/5 bracket x minus 2 close bracket cubed, right, and then plus 3 over 5. And there you go. Just quickly double check that your CAS output matches the function given to you. Okay, so part of the graph of f is shown below, and it's just as you'd imagine, it is a cubic graph. So part A, find f dash of x, the derivative of f, with respect to x. Okay, so this is a 1 marker, so we're just going to use our calculator. Shift minus d dx, var, choose f, x, and there we have it. So the derivative of this function is f dash of x is equal to, so copying what we have in the calculator, negative 6/5 x squared plus 24 over 5x minus 24 over 5. There we go. That's all we need to do for the mark. Part B, give the coordinates of the stationary point of f. Okay, so we can either have a look back at the original function, which basically, using our knowledge, the stationary point, which is a stationary point of inflection, should be at 2, 3 over 5. Okay, so that is 2, 3 and 5. We can, of course, double check that using our CAS as well. Menu 3, 1, solve the derivative equals 0 for x, and we certainly get x equals 2. And we can plug in var f of 2, and we get 3 on 5. So as predicted, the stationary point's coordinates are 2, 3 over 5. That's it for the mark as well. Part C. The graph of f has a tangent with the gradient of negative 6 over 5 when x equals 1. So the graph of f also has a tangent with the gradient of negative 6 over 5 at another point D. Show that the x-coordinate of D is 3. Okay, so this is a show that question, so we need to put a little bit of working into this. So the way we do this is we need to take the derivative f dash of x and equate that to negative 6 over 5. Okay, so f dash x is negative 6 over 5. So that means negative 6 over 5 is equal to, and then you copy down the derivative from part A, neg 6/5 x squared plus 24 over 5x minus 24 over 5. And now what we can do is we can basically use our calculator to help us sort of simplify what's going on over here. So in other words, what you do is you type in negative 6 over 5 equals, and simply keep pressing up and copy and paste the answer there. So we can now use a calculator to sort of help us simplify the equation so it's easily solvable. So we can multiply both sides by 5. That gets rid of all the denominators. We can then divide both sides by -6. We get 1 equals x squared minus 4x plus 4. We can then subtract 1 from both sides, and we end up with 0 equals x squared minus 4x plus 3. So this then leads to 0 equals, you can factorize this by hand or using CAS. Menu 32 is factor, and we basically get 0 equals x minus 3, x minus 1. So this leads to, therefore, x equals 1 or x equals 3. Now they already told us that the gradient is next to 6 over 5 when x equals 1, so we already know x equals 1 is one answer. So therefore, the x coordinate of D, so the x coordinate of point D is equal to 3. And there we go. For the mark, we've now done all the working to show that D has an x coordinate of 3. So part 2, determine the equation of the tangent that touches the graph of f at point D. Okay, so as we said before, at the point D, our x value is equal to 3. So the equation of the tangent, we'll use our calculator for this one. We need to write y equals, then menu 49 for tangent line, and then var f of x, comma, x equals 3. And there we have it. Y equals 19 over 5 minus 6 over 5x. And that is the equation of the tangent at point D. Excellent. Moving on to part 3 now. The tangent of to f at point D intersects the graph of f at another point M. Give the coordinates of point M. Okay, so what we need to do in this case is take the function f of x and equate that to the expression for the tangent. So 19 over 5 minus 6 over 5x. And we just simply need to solve that using the calculator. That will give us an x value of, now let's use the calculator, menu 3, 1, solve, and then we will put var f of x is equal to, now press up and then press right, hold the shift key down and keep pressing left, and that will copy and paste the right hand side, and then we put comma x, and you end up with x equals 0 or x equals 3. But x equals 3 is the point D. So the other point, therefore for point M, we have x equals 0, and therefore f of 0, we can press var f and then 0 is 19 over 5, f0 is 19 over 5, therefore the coordinates of M are 0, comma 19 over 5. Now there is another way we can do this on the calculator as well. Menu 371 for solve system of equations. This time we're just going to put y equals f of x, and at the bottom we can put the equation of the tangent. So Control C, go all the way down to the box, and Control V, and there we have it. So 0 and 19 over 5, or 3 and 1/5. So 3 and 1/5 is point D, and 0, 19 on 5 is the point M. There you go. For 2 marks, there are the coordinates of point M. Alright, moving on to the next part, part 4. We have to find the obtuse angle in degrees that the tangent to f at point D makes with the positive direction of the horizontal or x-axis. Okay, so we know that the gradient of this specific tangent is negative 6 over 5. Just quickly double checking that. Yep, you can see it's negative 6 over 5 is the gradient of the tangent. So therefore, this implies that the angle that it makes with the positive x-axis is equal to the inverse tan of negative 6 over 5. However, that value right there would be a negative angle. We need to add 180 degrees over to it to turn it into an obtuse angle. Now, given that our calculator is in radians mode, the way to do this is to do everything in radians and then convert to degrees. So press trig, go to inverse tan, negative 6 over 5, and then at the end add 180 degrees, which is the same as pi radians. Control Enter, we get 2.26 roughly in terms of radians. So to convert this to degrees in decimal place, we can either multiply by 180 over pi, or you can press the book button and find the right arrow DD option. That means decimal degrees. You press Enter, then Control Enter, and there we have it. So correct to one decimal place, the required angle is 129.8 degrees. Just make sure that degree symbol looks nice, and there we have it. Okay, moving on to part 5, we're looking at the graph having two regions, and the first region being bounded by the graph of f and the tangent f at point D. That's region number 1. And the second region is bounded by the graph of f, the tangent to f at point D, and the horizontal axis. And our job is to find the total area of the two regions. Okay, so in order to do this question, it'll probably be a good idea to draw the tangent on the graph. So let's look if we know any features of the tangent. Well, yes, in fact, in part 3, you can see what I've highlighted there. 0, 19 on 5 is the coordinates of the intersection between the tangent and the graph of f of x. So it turns out that the tangent and f of x intersect at their y-axis, or the y-intercept. So I'll use a red color to do this. So at x equals 3, what we've got is we've got a tangent that starts over here and heads towards the y-intercept as shown, and the tangent keeps on heading down to the bottom. So that hits the x-axis at that particular point. So in order to get this, find this area, so what are the regions that the question is talking about? Well, the first region is this region between the tangent and the graph of f of x. So that's the first region. And the second region is this little bit down at the bottom. So what you can do, I reckon the best way to get this one done is, let's find the area of this triangle. So from 0 to there, all the way to the tangent's x-intercept, and all the way up to the y-intercept there. Let's find the equation, find the area of that triangle, and then subtract the area of the cubic. All right, so in order to do that, we're going to need a few intercepts. So first things first, the x-intercept of the tangent, let's use the CAS for that. So menu 3, 1. Right, so menu 3, 1. We're going to take 19 over 5 minus 6 over 5x. That was the equation of the tangent. 6 on 5x is equal to 0, comma x. And there we have it, x equals 19 over 6. So that point there is 19 over 6, comma 0. And next thing, we can look at the x-intercept of the function f of x. So menu 3, 1, solve f of x equals 0, comma x. And there we have it. Okay, that looks like a pretty gnarly sort of thing. So let's write that out as well. So that is equal to, now you can actually sort of simplify that a little bit. So let's just double check what it would be. I reckon that is equal to the cube root of 3 over 2 and plus 2. Let's just double check that that is indeed the case. Yep, and it is true. Okay, so we can write that as the cube root of 3 over 2 plus 2, comma 0. The other thing as well is we know that that y-intercept there, if you look back at the equation of the tangent, it was 19 over 5. So that is 0, comma 19 over 5. Okay, so here's what we're going to do. We are going to take the equation of that triangle. So it's going to be half times the base times the height, and then subtract the integral of f of x between 0 and its x-intercept. Okay, let's go ahead and write all of that out. Okay, so here we go. The area is equal to, now the triangle, half times the x-intercept of the triangle. Let's look back in the CAS, was 19 over 6 was the base of the triangle, and the height of the triangle was 19 over 5. We're then going to subtract the integral from 0 to the x-intercept of the cubic, which was the cube root of 3 over 2 plus 2, and simply f of x dx. Okay, now let's type all that out into the calculator. So 1/2 times 19 over 6 times 19 over 5, and then subtract shift plus between 0 and that particular x-intercept, so we can copy it here using shift and the arrow keys, and then we're simply going to put f of x in there with respect to x, and there we have it. So the total area of the two regions is going to be roughly 2.7015, correct to 2 decimal places. Excellent, and there we go. That is the end of question 1. Okay, moving on to question 2. Before we do anything further, doc for 1. That'll add a new problem, and therefore we'll go to either a graphs or a calculator page is fine. So I'm just going to calculator page so we can define some functions. So Sally's using graph sketching software to design the landscape of the 4 hills shown in figure 1 below. Okay, she starts by using the square root functions h, h1, and h2 to model the shapes of 3 of the 4 hills as shown in figure 2 below. So we are told that h of x is root 2 minus x. So h of x is defined as root 2 minus x, enter, and there we have it. So that's h of x taken care of. Let me just highlight that for you. There we are. That's h of x taken care of. So state the maximal domain for h. Again, we can use the domain command on CAS, or you can solve this by hand. So domain, and then bracket h of x, and then comma x, and there we have it, negative infinity to 2. So the maximal domain of h is negative infinity all the way to 2, and the 2 has a square bracket because it is included. Okay, so the rule for the function h1 is obtained by reflecting the graph of h in the vertical axis. Right, so what we're going to do over here is when we reflect in the y-axis, what happens is that you take your function h of x, and your x gets replaced by negative x. So therefore, h1 of x is equal to the square root of 2 minus negative x, and that is equal to square root of 2 plus x. So therefore, h1 of x equals square root 2 plus x. That's what they'd like. So that is the rule for the function h1 of x. Okay, cool. So moving on to part B, the rule for the function h2 is h2x equals 2 root 3 minus x. So write a sequence of 2 transformations that map the graph of h onto the graph of h2. Right, so first things first, I'm actually going to write what h of x was over here. So h of x was, look at the CAS as well, it's basically root 2 minus x. Okay, so we need to take root 2 minus x and convert it into 2 root 3 minus x. So first things first, the 2 in front, that is a dilation by factor 2 from the x-axis. So that will get the 2 in front of the square root. Okay, now for the second dot point, we need to get root 2 minus x over to 3 minus x. So the best way to sort of do this, we need to do a little bit of working. So 2 minus x is the same as negative x minus 2. And 3 minus x, of course, for similar reasons, is negative bracket x minus 3. So we need to transform x minus 2 into x minus 3. And in order to do that, we need to translate to the right by 1. So when you translate to the right by 1, your negative x minus 2 minus 1 would be negative x minus 3, and that of course equals 3 minus x. So what we have is a horizontal translation of 1 unit to the right. And those are the two transformations that will do it. You can either say to the right or in the positive direction of the x-axis. Both will be acceptable. Right, there we go. Now, part 2. Let T1 of xy equals a0, 0b times xy plus cd be a transformation that maps the graph of h onto the graph of h2. Right, find one set of possible values for a, b, c, and d. Right, so here we go. So this directly follows what part 1 was, because part 1 we had to map h onto h2, and here we're also doing the same thing. We're mapping h onto h2. Right, so the dilation by factor 2 from the x-axis, so the dilation, that will give us b equals 2. And now, given that there's no dilation or reflection in the y-axis, we can basically say that a is just stuck at 1. So a does not change at all. And then the value of c, well, that is our translation. So as we said in the previous question, we are moving 1 to the right, which means c is equal to 1. And then there's no vertical translation, which means d equals 0. So putting all of that together, a is going to equal 1, b is going to equal 2, c is also going to equal 1, and then finally d is going to equal 0. There we have it. That is the matrix transformation done. Right, part 3. Find the value of x for which the slope of the hill defined by h is equal to the slope of the hill defined by the function h2. Okay, so what we're looking at here is we want h dash of x to equal h2 dash of x. So in other words, we're just equating the derivatives. So shift minus d dx of h of x, that is equal to negative 1 over 2 root 2 minus x. So we want that to equal the derivative of h2 dash. So shift minus d dx. And remember, h2 was 2 square root 3 minus x. And there we have it. So that's negative 1 over root 3 minus x. So we need to equate that, and we should get a single x value when we solve it on CAS. So menu 3, 1, go back all the way to h dash of x, and equate that to h2 dash of x, comma x, and there we have it. X equals 5/3. So at x equals 5/3, the slope of h equals the slope of h2. Perfect. Now let's go to the next part. Sally decides to use a quadratic function h3 to model the shape of the fourth hill in her landscape. So h3 is this function right here. It's that, basically that quadratic. Alright, so part C. Find the rule for h3, a quadratic function with the stationary point at 4, 6, and which passes through 2, 2. Alright, so this is a basic finding equation of quadratic sort of question. So we know that h3 of x, given that the stationary point, in other words the vertex, is at 4, 6, we can say that that's equal to a bracket x minus 4 squared plus 6. We know that it passes through 2, 2, so that means that h3 at 2 is equal to 2, and this implies that 2 equals a times 2 minus 4 squared plus 6. So this gives us 2 equals, 2 minus 4 is negative 2, negative 2 squared is 4. That's 4a plus 6. And solving that either by hand or using the CAS. Let's use the CAS for this one quickly. Menu 3-1. 2 equals 4a plus 6, comma a. We end up with a equals negative 1. So a equals negative 1. So therefore, the rule for H3, therefore, the rule for H3 of x is equal to negative 1, x minus 4 squared, and then plus 6 at the end. There we have it. That is the rule for H3. Awesome. So Sally believes the function H3 is closely related to the inverse of H. So find the domain and the rule for the function H neg 1, the inverse of Hx equals 2 minus x. Okay, so here we go. Let y equal Hx equals square root 2 minus x. And now for the inverse, we are going to swap x and y. So we're going to have x equals root 2 minus y. And this gives us y equals, so menu 3-1, x equals square root 2 minus y, and then comma y. So y equals 2 minus x squared. And we also get told on the calculator that x is greater than or equal to 0. So therefore, that is our domain. So therefore, the rule for the inverse is h inverse of x is equal to 2 minus x squared, and the domain of the inverse, as requested, is equal to 0 to infinity. So that's 0, comma, infinity. So you can either get the inverse as the calculator has shown, or you can also look at the range of the original graph. There we go. So 0, comma, infinity is number 1. It's the range of h of x, but it's also what the calculator gave us. Excellent. So part E. Consider the transformation T2 given by that matrix transformation. Does the transformation above map the function h onto the function h3? Give a reason to justify your answer. Okay, so what we could do here is understand what T2 is doing. So T2, number 1, the 0, 1, 1, 0, what that is it is a reflection in the line y equals x. That's first and foremost what that does. And then the 4, 4 means 4 right and 4 up. So we translate. So translation, we've got 4 right and 4 up. All right, so here's what's going to happen. When you reflect in the line y equals x, so after step 1, reflecting the line y equals x gives us y equals 2 minus x squared, which is what we saw in the previous part. So in the previous part, we saw the inverse of h of x basically is reflecting the line y equals x. We get y equals 2 minus x squared. That's what we get. Okay, now after 2, so after step 2, what's going to happen is we move right by 4. So that will give us 2 minus x minus 4 squared. And then we move up by 4, which adds 4. So that's equal to 2 plus 4 is 6 minus x minus 4 squared. which is really the same as negative x minus 4 squared plus 6. Now if you look back at the previous part of the question where h3 is, h3x is negative bracket x minus 4 squared plus 6. That's exactly what we've got here. So that is equal to h3 of x. So let's read the question again. What does it want? Does the transformation above map the function h onto the function h3? Yes, it does. So yes, t2 maps h onto h3. Done. That is all you need to do. Excellent. So moving on, now we've got a new question. So as always, doc for 1 to add a new problem. So the functions px and qx, so let's straight away define them. P of x is defined as 2 bracket 1 minus e to the negative x, and qx is defined as 2 bracket 1 plus e to the negative x. There we go. So that's what we've got, and we're defining them over all real numbers, so that's completely fine. Okay, so find the area bounded by the graphs of px and qx, and by the lines x equals 0 and x equals 1. Okay, now we're getting straight into an area question, so it's probably a good idea to actually sketch these functions and see what they look like, just in case there's any intersections, etc. So add a graphs page, and let's sketch p of x, and then let's sketch q of x. Okay, so that's what we've got. So we want the area bounded by those two graphs and by the lines x equals 0 and x equals 1. Right, so as we can see, just quickly moving this out of the way, we've got q of x on the top and p of x on the bottom, and we're looking at this area between them. Okay, so the area that we're looking for is as follows. It's the area between 0 and 1, and we have q of x on the top, so that's the red graph, minus p of x on the bottom. And close bracket that. We of course want to integrate that with respect to x. So let's go back to 4.1 and then shift plus 0 to 1, and like we've written down, we want q of x minus p of x. Okay, we want to integrate that with respect to x, and there we have it. Okay, so that area is equal to 4e to the negative 1, which is 4 over e, multiplied by e minus 1. And this is going to be units squared. Done. Okay, so state if p and q are each strictly increasing, strictly decreasing, or neither. Okay, so the quick way to work this out is let's work out the derivatives of p and q. Shift minus d dx of p of x. That's 2e to the negative x. Now, the derivative of p of x, as you can see, p of x is over here. The derivative of that is always positive. So 2e to the negative x is a function that is always above the x-axis. In other words, this graph is always going up. It's always strictly increasing. So we can say that p is strictly increasing okay, and then what about q? Well, q will have similar ideas to it. If we go back to 4.1 and then take the derivative of q of x, you'll get something similar. So q of x, and we get negative 2e to the negative x. So that is a function that is always below the x-axis, and as you can see on the graph is always decreasing. So q is strictly decreasing. There we go. Excellent. Just 1 mark for both of those answers. So, part C. Find the rules for the functions p neg 1 and q neg 1. Okay, so this one we can actually just use our calculator quickly to get this one done. So we're going to go menu 3.1, solve x equals p of y with respect to y, and we end up with this. So p inverse of x, p inverse of x is going to equal log e of negative 2 over x minus 2. And that is, of course, with x being less than 2. So you can write that restriction that the CAS gives us as well. And the inverse of q of x, given that this is 2 marks, we probably don't need to go through the whole rigmarole of letting y equals p of x and then doing the swap and everything. We're just finding the rules, and we can use our CAS certainly for that. So going back to the previous solve, we can just go there and change the p to q. Okay, let's try that again. So remove p and put q in its place. So remove p and then put q, enter, and then we get something similar. So this time it's log e of 2 over x minus 2. And this time the domain is x is greater than 2. There we go. So those are the inverses, respectively, of function p and function q. Okay, moving on to part D, we are looking at the point of intersection between p of x and the inverse of x, so p of x and q inverse of x. And point B is the intersection between q of x and p inverse of x. So our job is to work out the coordinates of A. Well, they actually gave us the coordinates of A. A is 2.329, 1.805. And our job is to work out the coordinates of B, corrected 3 decimal places. Right, so what we need to do is work out some inverses here. So for option point B, we're looking at q of x and p inverse of x. Right, so let's do this via a simultaneous solve. Menu 371, 2 equations x and y. So the first graph is going to be y equals q of x, y equals var q of x, and the bottom equation is going to be the inverse of p. So the inverse of p was y equals log e of negative 2 over x minus 2. So copying that one and going all the way down to the bottom and pasting it, and there we have it. So control enter, and there we are. So b is, the coordinates of b are 1.805, comma 2.329. And it turns out that that is pretty much just the swap of what point A was. So point A had x and y swapped compared to what point B was, which makes sense because we're looking at inverses over here. Right, so there we go. That is the coordinates of point B, and that's correct to 3 decimal places. So you can either, of course, use the calculator to verify that, but you can use the fact that they're inverses, so it just gets swapped out. So write the equation of the line that passes through points A and B in the form y equals mx plus c, give any approximate values correct to 3 decimal places. So this is just a basic, straightforward finding the equation of a line in the y equals mx plus c form. So first things first, we need to work out the gradient. So the gradient is just going to be y2 minus y1 over x2 minus x1. So 2.329 minus 1.805 divided by the difference in the x values is 1.805 minus 2.329. So our gradient is negative 1. So that's y equals negative x. So now let's work out the c value. So let's use the point gradient form of a straight line. Menu 3.1. Y minus a y value, 2.329, is equal to the gradient, negative 1, times x minus the respective x value, which was 1.805, and we're solving for y. And let's expand that one. Menu 3.3, expand. There we go. So y equals negative x plus 4.134. Plus 4.134. And there we have it. The approximate value is correct at 3 decimal places, so that is good to go. Excellent. So moving on. The function r is the product of functions p and q with rule given by r of x equals px times q of x. Okay, so part 1 asks us to show that r of x equals this particular thing. So because to show that, we can't really use our calculator to do the working. We have to do the working by hand, and then we can just verify it on our CAS. So r of x is equal to p of x multiplied by q of x. So we can either scroll back to get p of x, or you can just go back to your the definition. So going back to the definition, we saw that p of x is 2 times 1 minus e to the negative x, and q of x was 2 times 1 plus e to the negative x. Okay, so first things first, the 2 and the 2 will multiply to get 4. And then we have 1 minus e to the negative x times 1 plus e to the negative x. So we've got the same expression, just 1's minus 1's plus. That's perfect for difference of 2 squares. So it's the first squared minus the second squared. Or you can alternatively just use FOIL and just expand out the brackets that way. So that's equal to 4 bracket, 1 squared is 1, minus e to the negative x squared, that's just e to the negative 2x. And close the bracket. That's exactly what they want. So you can say comma as required. Done. That's showing r of x equals the respective quantity. Right, state the domain and the range of r of x. Alright, so for this one, well, the domain of r of x is just going to be all real numbers, given that the domain of p and q was all real numbers. You can also verify that on the CAS as well. So you can type in DOMAIN, and then I'm just going to write p of x times q of x. So p of x times and q of x. And we have to put comma x as well at the end. Don't forget that. So comma x. There we have, negative 50. So that basically the domain is all real numbers. So the domain of the function r is all real numbers. And the range of that, well, we can go back to our 4.2 and then basically create a new graph called p of x times q of x. Enter. Okay, and we get this this function here. So what's happening is we've got a horizontal asymptote, and what that means is the range of r is going to be negative infinity all the way up to whatever that horizontal asymptote is. So to get the value of the horizontal asymptote, remember that p of x and q of x both asymptoted at 2. As you can see, the red graph and the blue graph, they both asymptoted at 2. So when you multiply them together, the asymptote will be 4. And you can see that as well when you look at the function r. There's a 4 in front of it. So as x approaches infinity, this section of the graph will basically become 0, because x approaches infinity, e to the negative infinity is effectively 0. So 4 multiplied to 1 to get 4. So therefore, the range of r will be negative infinity all the way to 4, but both non-inclusive. There you go, 2 marks for that information. So find the rule for the function r neg 1. Give your answer in the form r neg 1 x equals that. Alright, so let's just use a calculator to work out what we could get by calculator and what we can then get by hand as well. So what we're going to do is, first of all, I'm going to define r of x. So r of x is defined as p of x times q of x. That's done. And now let's work out the inverse. So menu 3(1), x equals r of y, and we're going to solve for y. Enter. Okay, so we get y equals log e neg 4 over x minus 4 all over 2, and x is less than 4. So in this case, we can just say the inverse of r of x is equal to 1/2 log e of negative 4 over x minus 4, but then changing that output into their desired form, it's 1 over 2 log e. Now, because we saw that 1 over a is 1 over 2, a squared, of course, will be 4, and then because we multiply the top and bottom by negative 1, what we'll get on the bottom is 4 minus x. And that agrees with what we had from before. And that is 1 over 2 log e 4 over 4 minus x. And that right there is the rule for the inverse of r. Alright, so part F, part 1. Clearly state the equation of the line that the points of intersection between the function r and its inverse both lie on. Okay, so just to double check that, now normally the answer would be y equals x, because that's normally where the inverse and an original will intersect. It's always good to double check this information though. So going to a new graphs page, let's sketch the function r of x. That's what the function r of x looks like. And now let's sketch the inverse. So to sketch the inverse, I'm going to change my graph entry to relation mode, and then just put in x equals var so x equals var r of y. There we go. So you can see the two functions, they look like that. And if we draw y equals x, which is where we assume it would be, there we go. The intersections clearly both lie on the line y equals x. So, yeah, the equation of the line that the points of intersection lie on is the line y equals x. Perfect. Right, find the coordinates of the points of intersection between the function r and inverse. Give your answers correct to 3 decimal places. Right, so we simply need to work out the intersection points between these, and we can actually do that on the graph, given we've got the graph open already. So menu, geometry, points and lines, and then we can find the intersection points. So we can look at the pink graph and the blue graph. So do we have any more decimal places? Yeah, so it says 4 there, but in fact it's hiding more than that. So just simply hover over each of the numbers and press the plus button, and if there's any decimal places that appear, they will appear for you. So we have the first intersection point. So basically we can say, if we take Rx and equate it to R neg 1x, alternatively equate it to x, you'll get the same either in either combination you take. Then what you will get is you get intersection points at 0, 0 and at 3.999, 3 decimal places we want. So 3.999, comma, and the other one is also 3.999. There we go. So those are the 2 coordinates of the intersection points. And there we have it. That's that question done. Now, moving on to question 4. So as always, doc 4.1 to create a new problem. So, a bakery sells glazed donuts. The probability density function that describes the thickness of the glaze on a glazed donuts is given by the function that. Okay, so let me just, let's just go ahead and define that. So, f of x is defined as, and because there's only one non-zero section of the function, we just need to define that one, just to make it easy for ourselves, rather than going for the whole hybrid function. Neg 108, and then x cubed minus 6x squared. Done. Right, show that the mean thickness of the glaze on the bakery's donuts is mu equals 18 over 5. Okay, so mu is equal to, this is the mean, so it's e of x, and the only show we need to do is show the integral from 0 to 6 of x multiplied by f of x with respect to x. So you simply take your function and multiply it by x and then integrate. So shift plus integral from 0 to 6 of x times, and you can press var f of x and then go all the way to dx, and there you have it, equals 18 over 5. That's exactly what they wanted. Job done. Okay, so that's the mean done. Find the standard deviation of the thickness of the glaze in millimeters. Okay, so the standard deviation is the square root of the variance, which is equal to the square root of the expected value of x squared minus the mean squared. So this one, let's write it over here. The expected value of x squared is the same integral as before, except we now have x squared instead of x. So x squared fx dx minus 18 over 5 squared, which is the mean. So that is equal to, let's work that out. So we can press up twice and just modify the integral to chuck a square on the x. There you have it. So 72 and 5. So that's the square root of 72 over 5 minus, and then 18 over 5 squared is 324 and 25. And then there we go. So let's just square root the difference between 72 and 5 and 324 and 25, and we just get 6 over 5, and that's going to be in millimeters. There we go. That's the standard deviation. So part B, part 1, find the median thickness of the glaze in millimeters, correct to 4 decimal places. Okay, so if we let the median be at m, then this means that the integral from 0 to m of f of x with respect to x is going to equal half, because the median is the x value that divides the area into 2 equal halves. So let's do a menu 3, 1, and then shift plus 0 to m of f of x dx is equal to 1/2, and we're going to solve for m and control enter, and we get these two values here. Now, given that we have two values, the second value is actually outside of the domain. Remember, our domain needs to be between 0 and 6. So therefore, we simply need to write m is equal to, we want 4 decimal places, so 3.6856. 6856, and that's going to be in millimeters as well. There we go. That's the median thickness of the glaze. Okay, find the probability that the thickness of the glaze on a randomly selected donut is greater than 2, given that the thickness is less than the median. Okay, so this is a conditional probability because they've got the word given. So this is what they want. PR, let's just double check if they've defined the thickness as x or something. Yep, they've defined it as x, so we can use x as a random variable. So PR of x is greater than 2, given that the thickness is less than the median. So x is less than the median. So we need to intersect these two. That's PRX greater than 2, intersect SX less than the median. Remembering the median is 3.6856 over PRX less than the median. So this simplifies to PR. Now if you're greater than 2 and less than the median, it means you're between 2 and the median, divided by PRX less than the median. Okay, so the numerator, we're going to have the integral from 2 to 3 point. So the 2 on the bottom, and the top is going to be 3.6856 dot 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 6856 dot 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 of f of x dx, and the denominator, well, with the denominator, it's actually just going to be equal to a half, because by definition, if your probability is everything under the median, well, the median divides it into 2, so we just have to divide by 1/2. So you just need to work out what the numerator is. So shift plus. Before we do that, actually, we can just work out, get the median just by itself. So we're going to repeat the solve, but now tell the calculator that the domain is between 0 and 6. And that gives us the median just by itself. So now what we can do is we can go shift plus, and then 2 up to m, and then f of x with respect to x. But then we can also tell the calculator, okay, given that the median equals that. So we're not dropping any decimal places, we're using everything as much as possible. So that's the numerator. Then we divide that answer by half, and we'll end up with an answer of 0.78, corrected 2 decimal places. So 0.78. There we go. That's the probability that's been requested. Okay, moving on. So the bakery also sells donuts with the custard filling. The amount of custard filling in a custard donut has a normal distribution with a mean of 22 and standard deviation of 2. So we want the probability that a randomly selected custard donut has between 21.5 and 25 mil of custard filling. Okay, so we're going to let C be the amount of custard filling, and we are told it's normally distributed with a mean of 22 and a standard deviation of 2. That is a variance of 2 squared. So we want the probability that C is between 21.5 and 25. So we're going to use our norm CDF on the calculator. Menu 552 is norm CDF, 21.5 to 25. Our mu is 22, sigma is 2, and there we have it. So correct to 4 decimal places, we've got an answer of 0.5319. Done. So the bakery also sells donuts with a jam filling. The amount of jam filling in a jam donut follows a normal distribution. It's known that on average 95% of jam donuts have at least 15.1 mil, and 10% of donuts have more than 23.9 mil of jam filling. Find the mean and standard deviation. Okay, so we know that we've got normal distribution as well. So we're going to say let J equal amount of jam filling and we don't know the mean or the standard deviation. So all we know is that x is not x, j. So all we know is that j is normally distributed with a mean of mu and a standard deviation of sigma, or a variance of sigma squared. So we are told, let's look at the information given to us. We are told that 95% of jam donuts have at least 15.1. So j greater than or equal to 15.1 is equal to 0.95. Now, because we are eventually going to use inverse normal, we need to convert the greater than to a less than. So that is PRJ less than 15.1 is equal to 0.05. So I'm going to call that equation 1. And the other one we know is that 10% of donuts have more than 23.9. So PRJ greater than, or this is just greater than, because more than 23.9. It doesn't really matter, but it's good to keep your notation sorted. So 10% of donuts, that's 0.10, have greater than 23.9 mil. So this means, in the opposite direction, PRJ less than or equal to 23.9 is equal to 0.90. And that right there is equation 2. Right, so now we're going to convert equation 1 and 2 into standardized form. So from equation 1, this implies that if we standardize it, so J standardizes to Z, and Z and 15.1 will standardize to 15.1 minus mu all over sigma, and that equals 0.05. And a similar way, equation 2 will standardize to PR Z less than equal to 23.9 minus mu over sigma equals 0.90. Okay, so for the top one, we can then say, because we've now got it standardized, we can inverse normal the right hand side and equate that to the inner compartment. So 15.1 minus mu over sigma is equal to the inverse normal of 0.05. So menu 553 is inverse normal. You just need to type in 0.05. Because we're looking at Z, 0 and 1 are the default settings, and we're going to use that. That's equal to negative 1.644 dot dot dot. And the second one implies that 23.9 minus mu 23.9 minus mu over sigma is equal to, and we go to the inverse normal again, menu 553, this time of 0.9, and we get 1.281 dot dot dot. So solving these simultaneously, we should get a value of mu and a value of sigma. So we want both these correct to the nearest millimeter. Right, so let's do this. Menu 371, two equations, and we'll use x and y just for easiness of use. So we're going to create a fraction, 15.1 minus x for the mean and y for the standard deviation. That equals the negative 1.64. Another fraction on the bottom, 23.9 minus x over y is equal to 1.28. So I'm just going to copy that, Control C, go all the way to the bottom, and then Control V, and then Control Enter, and there we have it. So mu, correct to the nearest millimeter, is going to be just 20. So the mean is 20, and standard deviation, correct to the nearest millimeter, is going to be 3. And there we have it. So that was a stock standard question where you have to go from probabilities back to the mu and sigma. Right. A random selection of the bakery's donuts is packed into boxes. The proportion of custard donuts as a proportion of all donuts is 0.44. Okay, so find the expected number of custard donuts in a box of 25 donuts. Right, so the expected number of custard donuts, well, we have 25 donuts, and the proportion of custard donuts is 0.44, so you simply multiply the two of them. So 25 times 0.44, and we've got 11. So there we go. So you'd expect 11 of the donuts in the box to be custard donuts. So find the probability that in a box of 25 donuts, there are at most 7 custard donuts. Use a binomial probability calculation and give your answer correct to 4 decimal places. Okay, so have we used C? Yes, we have used C before in option C. So yeah, we're just going to change over to using a different letter. So I'm going to use D for donuts, or we actually just use CD for custard donuts. Find the probability that in a box of 25, there are at most 7. So custard donuts is binomial with a sample size of 25 and a probability of success of 0.44. So therefore, we want the probability that there are at most 7 custard donuts. So that means CD is less than or equal to 7. This is a binom CDF. So menu 55B, number of trials is 25, success is 0.44, lower bound is 0, and upper bound is 7. And we get an answer correct to 4 decimal places of 0.0773. Let's make that 0 a little bit better. That's better. Cool. So 0.0773 is the required probability. Right. Find the minimum number of donuts required in a box to ensure that the probability of having at least 12 custard donuts is greater than 90%. Okay, so in this case, we have a different distribution again. This time, it's binomial. I'm going to call it y, because we've used x already. Y is binomial with an unknown sample size and a probability of success of custard donuts of 0.44. So what we want is the probability of having at least 12 custard donuts, so y greater than or equal to 12, we want that to be greater than 0.9. So we need to convert that into the opposite. We need it to be less than or equal to. So that is PR, y less than or equal to 11 is less than or equal to 0.1. This should give us an n value, which we can find using inverse binomial n. Menu 55D. So the cumulative probability is 0.1. Our success is 0.44. And the max successes is 11. And there we have it. Our n value, so the minimum number of donuts, so our n min is equal to 35. So we need to have 35 donuts at a minimum in the box to get a greater than 90% chance of having at least 12 custard donuts. Alright, so the bakery staff want to determine whether their customers think their donuts are delicious. In a random sample of 64 customers, 30 customers said that the bakery's donuts were delicious. So let P hat be the random variable representing the sample proportions in samples of size 64. Okay, so let's write down a couple of things first of all. So 64 customers, that means our n value is 64. We know that 30 customers said that the donuts were delicious. So in this sample, our x value is 30, and therefore we can say that the sample proportion in this specific sample is equal to 30 over 64, which we can simplify to 15 over 32. So that's the value of p hat for the specific sample that's just been taken. Okay, so p hat is a random variable representing the sample proportions. So we need to find the standard deviation of p hat correct to 4 decimal places. So the standard deviation of capital P hat would normally require the value of p, the population proportion, but we don't have that over here. Currently we only got a p hat value. So I'm just going to write p hat bracket 1 minus p hat over n. So that's equal to 15 over 32 is the value of p hat times 1 minus 15 over 32 all over n, which is 64. So let's put that in the cas. So square root of 15 over 32 times 1 minus 15 over 32 all over 64, and there we have it. So that is equal to, and it also wants 4 decimal places, sorry. So we want 0.062 6237, which is 624. That's the standard deviation of p hat. So find approximate 95% confidence interval using the sample proportion of customers who said that they're delicious, correct to 4 decimal places. Okay, so we can just use, we don't need to use the formula for this one. We can just go straight to the confidence interval command on the cas. So menu 665 and successes. Well, we know that there are 30 successes. The n value sample size is 64, and we want a 95% confidence interval. Control enter, and there we have it. So the lower part of the confidence interval is 0.3465, and the upper part of the confidence interval is 0.5910. There we go. Alright, so we'll mark for all of these because it's pretty basic calculations that you can get done quickly using your CAS. Okay, interpret the confidence interval you found in part G, part 2 in relation to the proportion of customers who said that the bakery's donuts are delicious. Okay, so what we're saying over here is that, okay, so we have to interpret this confidence interval. So the confidence interval found Okay, show that. So the meaning for the confidence interval over here is that you would expect 95% of these confidence intervals to contain the true population proportion. So this confidence interval found shows that there is a 95% probability sorry, that's not the right word. It's not 95% probability. Okay, you have to be very careful with the wording for this. Okay, shows that 95% of all 95% CIs are expected to contain the value of P. So the value of P, where P is the population proportion. So basically what we did was we calculated this 95% confidence interval for one specific sample, and then what you do is you take more samples and you keep calculating confidence interval. You'd expect 95% of those confidence intervals to contain the actual true value of P. Okay, so that's one way to answer the question. You can of course change the words around, but we need to get the idea across that 95% of all these 95% confidence intervals will be expected to contain the actual value of P. Okay, the population proportion it should be. And there we have it. Okay, so that's that question done. Now moving on to what I believe is the final question of the exam. So doc 4.1 again, add calculator, and what have we got? So spring with the weight attached to suspended from a stand. The base of the weight is 40 centimeters above a bench. The spring is released and moves vertically up and down, and we are told that the height of the base of the weight is given by a function. So let's define that function first of all. So h of t is defined as 20 e to the negative t over 5 times cos of 2 pi t and then plus 20. Okay, so just defining h of t, where t is the time. A graph of the function h over the first 10 seconds is shown below. So here we have it. This graph shows how h varies according to time, and we've got b1 and b2 given to us. So the dash curve b1 lies above the graph of h, and the dash curve b2 lies below the graph of h. Both b1 and b2 bound the graph of h. So what that's saying is the graph of h is completely between the graphs of b1 and b2. So the dash curve b1 has the equation b1t equals 20 e to the negative t on 5 plus 20. So it's talking about this particular graph right there. So that is b1. So we need to state the equation of the dash curve b2. Okay, now the equation of the dash curve b2 is pretty much the same as b1, except that it's reflected, but not in the t-axis. It's reflected in the line y equals 20. So what's going on is, as you can see, y equals 20 is basically the line of symmetry between b1 and b2. So just reflecting it in the line y equals 20 is quite easy, because as you can see, we have a plus 20 for b1. So b2 is actually going to be very similar. b2t will also have the plus 20, except that the exponential term will just be upside down. So that's negative 20 e to the negative t over 5, and then plus 20. And you can use your calculator to verify that as well if you so wish. So find the average value of the height of the base of the weight above the bench over the first 10 seconds. So we want just the average height. So this one, we're going to use our average value formula. HAV equals 1 over 10 seconds minus 0 seconds times the integral between 0 and 10 of the function h of t with respect to time. So that is here. So control that. 1 over 10 minus 0 times shift plus integral 0 to 10 of h of t with respect to t. And there we are, 2 decimal places. So the average height will be 20.01. 01, and that will be in centimeters. There you go, that's the average height over the first 10 seconds. So, part C, part 1, write down the rule for the derivative of h. This one, just use the calculator. Shift minus d dt, and we're going to put h of t. Okay, so we've got that there. Let's see if we can factorize it to make it look a little bit neater. Menu 3, 2. Okay, not really, but we'll just write that as it is, just to make it a little bit shorter. So h dash of t is the derivative, is equal to negative 4 e to the negative t over 5, and then times cos of 2 pi t, cos 2 pi t, and then plus 10 pi, sine of the same argument. 10 pi sine of 2 pi t. Of course, the expanded version will be acceptable as well. So one marker, you basically just put it in the calculator and write down the output. There we go. Okay, part 2. Find the time in seconds and the height above the surface of the bench in centimeters of the point of maximum positive rate of change in h over the first 10 seconds. Write your answer as a coordinate pair correct to 1 decimal place. Okay, so we're looking for the maximum positive rate of change of h. So if you look back here, we're basically looking for the time at which the graph is rising most rapidly. So as you can see, as time goes on, the graph is rising but not as steep, and as you keep going more and more left, you'll notice that the rate of increase keeps increasing. So what that means is the largest increase would be right there at that point. So somewhere between half and 1, right there, we're going to have the most positive rate of change of h. So what we're going to do is we want to maximize the function h dash of t. And one way to do that is we can sketch the graph as well. So we can go Control I, add graphs, and we can write the h dash of t. So we can put the derivative, my bad. So shift minus the derivative, and we'll put with respect to x of h of x, given that the graphs page only allows x, as a variable. There we go. Okay, so we've got a lot going on over here. Let's change our window settings. Menu 4.1. We only want it between 0 and 10, and then let's do zoom fit. Menu 4A for zoom fit. There we go. So as we assumed, the largest rate of change occurs at that point there. So let's work out the value of that point. Menu, analyze maximum, there to there. There we go. So 0.74, we want it to 1 decimal place. So what I'm going to say is working is sketching h dash of t, the maximum. Okay, so this is the very largest maximum. So this is what we would call an absolute maximum. Occurs at the point where t equals 0.1 I might just write some more decimal places just so we can keep everything accurate. So 0.739, 0.739 dot dot dot. So therefore, the h value, so the height value at this point, 0.739 dot dot dot. So what I might do is just get some more decimal places there, and then click that, and then we can copy it. So we can just go Control C, copying that number, and then going back to 6.1, and then var h, and then we can paste it in. Let's just maybe copy that again. You can double click it, there you go, and then double click and copy that, go back to 6.1 and Control V, paste it, and there we have it, 18.9 equals 18.9. So therefore, h dash is max at the coordinate 0.7, we only want one decimal place, 0.7, comma, 18.9. We could also have gotten the answers using derivatives, but the graph is probably an easier way to sort of see what is going on. Alright, have we answered everything? Write the answers a coordinate pair. Yep, that's all we need to do. So determine the total distance traveled by the base over the first 2 seconds of its motion. Give your answer correct to the nearest centimeter. Okay, to answer this question, there are a couple of ways that we've got available to us. The first one is the long way, which is to basically take the maximum, then the minimum, then the maximum, then the minimum, then that maximum, and basically subtract the minimums from the maximums, add all that together to get the total distance. The alternative way that we have available to us, though, is a lot more efficient, and this is how that alternative method works. Look back at 6.2 at the graph of the derivative. This is a graph of the speed of the mass with respect to, or rather it's the velocity. It's going downwards, then it's going upwards, then it's going downwards, etc. So if we could somehow get the total area under this graph between 0 and 2, let me just change the window settings. So window settings, I'll make the maximum equal to 2. Then we've got something a little bit better. So you've got the bottom area plus the top plus the bottom plus the top as well. What we can do is we can create a new function which is the absolute value of this. So that just converts everything to positive. So pressing the template button and then going to the absolute value, press enter, and then we put in f1 of x. f1 of x. So now what this does is any negative components, it reflects in the x-axis or in the t-axis in this particular case. So now what we can do is we can take the total area under this graph between 0 and 2. That can be done on the graphs page as well. So before we do that, maybe write down what we're going to be doing. So we can say our distance is equal to the integral from 0 to 2 of the absolute value of the derivative. So the absolute value simply makes all the negative parts of the derivative into positives, and then we are allowed to find the area after that. So doing it in the graphs page, we can go Menu, Analyze, and Integral, and the graph is of course the red one, and we can start at 0 and go all the way till 2. And we can see the answer is 132. Let's double check that in a calculator page. So Shift plus 0 to 2, and the function, the red function, was f2 of x. With respect to x, Control Enter, and we certainly do get 132. The question does want it correct to the nearest centimeter, so the answer is 132 centimeters, which is the total distance traveled by the base of the weight over the first 2 seconds. Moving on, look what we have. We are now finally at the end of the question and answer book. So that is the end of our exam. Thanks for checking out this video. I hope you've learned something from it. So see you next time for the next video.